All right, this is the last page, trying to finish up the review. Last question says, the diagram below represents two pulses approaching each other from opposite directions. Which diagram best represents the medium after they've passed through each other? This is one that kind of tricks kids. You all know what the answer is when they meet in the middle. It ends up being a bigger pulse. But what happens after they pass through each other? When we demonstrate it, a lot of times it looks like one bounces back and the other one bounces back. That's totally false. What happens is they just continue moving onward after they've interfered. So this one would be over here now. I drew a little too big. This one would be over here now. So they continue going through each other. When they meet in the middle, they interfere and something happens, but then they continue going on after. So I think the answer is A. All right. Next question. A student generates a series of transverse waves of varying frequency by shaking one end of a loose spring. All the waves move along the spring at a speed of 6 meters per second. So we know V is 6 meters per second. Our equation that relates these is V equals F lambda. So they give you the table here. If they're all traveling at 6 meters per second, you're given the frequency. Let's say it's 1 hertz for this first point here. The wavelength is going to be 6 meters. When it's, so you're solving for lambda. When it's 2 hertz, lambda is going to be 3. When it's 3 hertz, lambda is going to be 2 meters. And when it's 6 hertz, I don't know what I'm doing there, it's going to be 1 meter. So it looks like 3, 2, 1. So I completed the data table. And then on the grid provided, I'll graph it. So when the frequency is 1, the wavelength is 6. Whoops, does not like that. Maybe I'll just make this bigger. When the wave frequency is 2, the wavelength is 3. When it's 3, it's 2. And when it's 6, it's 1. That's interesting. If I was going to do a best fit, I would kind of go like that. Complete the table. We did that on the grid provided, plot it, and then draw a best fit line or curve. I guess I'm done. So it's, what type of relationship is this? It's an inverse relationship, which we knew that if we solve for F, it's V over lambda, or if we solve for lambda, it's V over F. Either way, lambda and F are inverses of each other, so the graph should look like that. All right, last question. Diagram below represents a periodic transverse wave traveling in a uniform medium. Draw a wave having both a smaller amplitude and the same wavelength. So the same wavelength means these points are good. What's different is the amplitude. It has to be smaller, so I'm going to put a point there and then connect the dots. And that's it. If they ask for, we have a little bit of time here, if they wanted a wavelength that was twice as long, what I would do is I would pick this point here and a point out here, and the midpoint would be right there, and I would go like that. If they wanted one that was twice as short, I would change the thickness of this, and I would say this is the point where it's a full wave, so I'd pick the halfway point there, halfway there, and that would be half as long a wave. So I hope this helped. Good luck with your group test tomorrow. Hopefully the people that get this can do even better by teaching the other people, and the people that are struggling can benefit from people that know what they're doing a little bit better. All right, study and good luck.